Second day of computer aided design, FEM, generative design, and CAM of using Fusion 360. So the second day of FEM, I will explain how to use the modal analysis in Fusion 360. Modal analysis is used to determine the natural frequency. So first you have to open the workspace, simulation workspace. So I will open the simulation workspace. I will click on the simulation workspace. Now you can see a new window opened. So from this window, you can select the analysis, type of analysis. So here you can see a new window, that is new study window. From this new study window, I will select the second option, that is the modal frequencies. I will select the modal frequencies and then I will click the create study option. So here in the browser, you can see in the browser tab, you can see study number 1. So this is study number 1, that is modal frequencies. So modal frequencies is used to determine the natural frequency. Then I will set the number of modes. Then I will define the mesh size and I will select the desired unit system. And after that, I will add the material. So first I will change the unit. So here I will use the unit system as metric SI. I will click on the units custom. I will double click on the units custom and I will change the default unit set into metric SI. Then I will click OK. So unit system is fixed as metric SI. Then the next option is I will enter the number of modes. I will enter the number of modes. So I will select the manage tab, go to manage tab, then click settings. Now you can see a new window open, that is the settings window. You have to select the study type as modal frequencies, that is the second option. Then you have to enter the number of modes. So here the default value of the number of modes is 8. So I will enter the number of modes to 12. Then I will click OK. Again, go to manage tab, settings. Then I will change the mesh. I will change the mesh size into 1.2 millimeter. So here I will click the absolute size. The absolute size is 10 millimeter. I will change this into 1.2 millimeter. Then I will click OK. So I have set the number of modes. I have defined the mesh system. I have entered the desired unit system. So then I will open the file that is tuning fork. So I will open the CAD file, that is tuning fork A4. Go to the data panel. click on the data panel, then select number 11, that is the simulation. Then you have to select the last option, that is tuning fork A4. Double click on the tuning fork A4. So now you can see the tuning fork is displayed in the screen. Yeah. Then I will save this. Click Save As. And then I will save this tuning fork A4, say 2.0, and I will save this. Then the next option is I will change the material. I will add the material as stainless steel AISI 304. I will change the tuning fork material to stainless steel AISI 304. So I will open the simulation workspace. I will open the simulation workspace. Then once again I will change the unit system into metric SI, then click OK. Then Manage tab, Settings, select the study type as modal frequencies, then number of modes into 12, then mesh, absolute size of the mesh into 1.2 millimeter. Then I will click OK. Then I will add the material, click Material, Study Material. So here you can see this tuning fork. The material is stainless steel AISI 304. So I will select stainless steel AISI 304. Then I will click OK. So now my material is changed into stainless steel AISI 304. So then I will solve the analysis and review the results. I will click the solve button and click the solve. So here you can see two options, that is you can solve it using cloud or you can solve it using locally. And here you can see the cloud credit account. So here the cloud credit account is education. So I will click this option. Here you can see solve one study. So click on this solve one study. I will click this solve one study. So here you can see the status, the simulation status. Here this is the simulation status is going on, and here you can see the name. The first one you can see the name. This is the name, tuning fork K4 2.0, and here this is the solve option. So here I am using the cloud option, solve it using the cloud option, and here this is the action. So if you want to cancel this, you can click this by click the cancel button for canceling this. So that is the job status simulation option. So here in the left side, another two option, that is generative design option and a data option. So when I will click Data, you can see there are no data jobs in progress. Generative designs, there are no generative design jobs in progress for open documents, only simulation. So here, once my result is completed, you can see the status of this. This is completed. The status is complete. So here, action, you can see the results. So I will click the close button. Yeah. So here, that was the result of this modal analysis. So here you can see that the results will be the total modal displacement, the modal displacement x, the modal displacement y, and the modal displacement z. So I will click the total modal displacement, and here you can see how many modes. So in the initial stage, I have entered the number of modes is 12. So here you can see the different modes, mode 1 to mode 12 and its frequencies. So mode 1 to 5, you can see the frequencies is 0 Hertz, mode 6, mode 7, 8, 9, 10, 11, 12. So these are the different modes and its corresponding frequencies. So if you want to see the animation, so I will click the animate button, and I will animate the first mode. I will click the play button, and I will change the speed to fastest, and I will click the two-way option. So this is the first mode. This is the first mode. Okay, then I will select the second mode. So here you can see this is the second mode. Then I will change into the third mode. So this is the mode 3, and this is the mode 4. Then mode number 5. Then mode number 6. Mode number 7. Mode 8. Then mode 9. Mode 10. Mode 11. And mode 12. So this is the modal displacement X, mode 12, and this is the modal displacement Y, and this is the modal displacement Z. So I will click on the total modal displacement, and I will select mode number 7. So here you can see the maximum displacement and the minimum displacement also. Okay, so that was all about the natural frequency analysis, the modal frequency analysis using Autodesk Fusion 360. So you have to practice this in Fusion 360, and you have to submit this as your second assignment. Thank you.